Hello, my name is David C., and we're here for AP Physics. Um, let's see. I imagine that what you would like is a little bit about the teacher who's going to be teaching your students, a bit about the course and what the course is about and how it's structured, and then maybe some advice on how you can help your students or how your students can, you know, succeed in the course. So let me take you to a PowerPoint presentation if you don't mind, and we'll go ahead and use that to structure this. So first off, my name is David C. It's spelled thusly. Here, why don't we do the fancy presentation? Sure, why not? Let's see here. This is my 20th year teaching this course, I think. Yeah, I think this is my 20th year teaching the course, my 21st year at Waubonsie. Let's see. I grew up in Wheaton, Illinois. Always knew I was interested in science, interested in how things worked and how everything went together, gave things their properties and made things do what they do. And when I was going to college, I was thinking about. I always knew I wanted something in the physical sciences. Chemistry seemed pretty straightforward to me, and was good at math, and so chemical engineering seemed like a good idea. Went to U of I. As I was going there, the way I got through college, the way I paid for it was by working a semester, school semester, work a semester, school semester. I was in this cooperative education program where I worked in a research lab, and that gave me kind of some exposure to the chemical engineering profession, and also let me realize by junior year or so that wasn't really what I wanted to do with my life. And so I thought a lot about what it was that would make more sense for me. And when I thought about it, I realized that I always have enjoyed explaining things to people. And I like the idea that when you're teaching, you're doing something positive with your life. You're helping people to learn and grow and become better people. And a lot of people that I kind of admired growing up were teachers. And so I thought about it. And so, but being a chemical engineering major was what was paying for my degree. So I went ahead and finished up the degree, and it was interesting, really cool stuff. And I learned a lot, stuff that I use in my teaching. But after I graduated, I went ahead and substitute taught for a semester to make sure that teaching was really what I wanted to do. And I was convinced. So then I went and got certified to teach through Wheaton College. That required 2 years, including student teaching and that whole deal. And it was definitely the right thing. This is what I was meant to do with my life. Since then, I've gotten a master's in curriculum instruction. Let's see. My family. I have married with 2 sons, Andrew and Nathan. My wife Erica. These pictures are a little old. Nathan just had his 10th birthday at the start of the month, and Andrew will have his 11th birthday in just a few days on the 23rd. So they're just slightly under 1 year apart. They're in the same year in school, in fact. Let's see. My interests besides my family is my favorite book is Ender's Game. I find that just very, very exciting and interesting book. And it's interesting. So much of it takes place inside the main character's head as he's, processing what's going on and figuring things out and learning about leadership. And it's a really, really excellent book. The movie does not do it justice. Read the book. Favorite movie is Lord of the Rings. Lord of the Rings has a special place in my heart. First read it when I was in 4th grade with my brother. We kind of took turns passing off the books as we finished them to each other. Was very, very happy with the job they did putting those movies together. Favorite musical groups, Rush. And then activities, I spent a lot of time reading, playing board games, video games, gardening. Let's see. But what we're here for is physics. Physics is the study of interaction of energy and matter. A lot of people would say. I like to think of it as the search for the fundamental laws that govern the universe, the basic rules that control how everything works. In first year physics, we spend a lot of time building up an understanding, starting at the very foundational material and kind of building up mechanics. We actually go over that material in much more depth in AP Physics. And one of the main significant changes is that we are going to use calculus. And that's going to allow us to deal with situations that are much more complicated, with things changing all the time rather than dealing with these special static conditions. It will give us a more rich and full view of how things are working. Physics, this physics course is actually called AP Physics C. There are also AP Physics 1 and 2 courses out there, but our district offers AP Physics C, which is the course that is for science and engineering majors. It's the physics for people that are going to need to use the physics course that uses calculus throughout. People who are a science and engineering major, of course, they're not just going to take 1 year of physics, they're going to take 3 or 4 or more semesters of physics. But we are representing the first year of physics, college physics here. So it'll be a semester on mechanics and a semester on electricity and magnetism. After that, students would tend to take like a course on like waves, light, and sound, and optics, and perhaps then another course that would be on quantum mechanics, and of course on thermodynamics, and maybe a fluid dynamics. Anyway, but we're just concerned with those first 2 semesters, mechanics and electricity and magnetism. And those are actually on the AP exam, it's like 2 separate exams, and you get credit independently on each one. So we split up between mechanics and E&M, try to do that relatively evenly. So the left column, the topics should look very familiar, look a lot like what we did this last year in honors physics or regular physics. A couple differences. We have rotation this year. We did not study rotational motion and spinning of objects last year. We also did not do simple harmonic motion last year, things that oscillate back and forth in a special pattern. Under forces, we'll be doing air resistance, which we didn't do before. There's every unit has some new twists and new wrinkles that we're putting in that the students didn't see last year. And now they're a little more capable. They've got some more mathematics and some more understanding. We're going to go just that next level deeper. Second semester, we'll have electrostatics, voltage and capacitance, circuits, magnetism, induction, which is fascinating and interesting stuff. Things that oftentimes you can't see with your naked eye, looking at these charges flowing around, but instead you're seeing things kind of secondhand, their effects, and having to figure out from that what the cause is and the root mechanisms, which is very interesting. So that's it makes me sad how much of this we're now having to do virtually. Now, it turns out there are a lot of really good simulations online. And so labs will oftentimes, we're going to have to do it virtually. And so I can do it a few ways. One way is there's these really cool simulations online that they can even, virtually do the experiments and take data. Sometimes I maybe I'll film kind of the experimental setups and kind of take some data and let them see how it works, and then share my data with them that they can analyze then. AP exam lab procedures and analysis of data is a real emphasis. And so it's something that they need to be able to do. They'll have regular homework sets. I'm going to try to push everything out to them through Google Classroom. So they'll be getting their materials through Google Classroom, like their the homework problems, and that normally they'll be getting in a packet. I'm just going to send it to them through Google Classroom, and their textbook is online. If they really want a hard copy, I can get them one, but it is online along with some really nice conceptual questions that the author put together. There are full solutions posted for every problem in the book. The other problems that are in the packets, I will post solutions for those too, so that they'll have those, so they can check their work. The idea is that they try the problem set, and then they go to the solution, and then they check through the solution. Any problem they don't get right the first time, it is expected that they will correctly solve every problem in the course. After they've tried it, check the solution, they're then to go back and retry any problems they didn't get right the first time. And again, that's how we learn. Okay, the problems in this course are challenging, very challenging, and I don't necessarily. It is not. I've never had a student who could just work all the problems the first time through and get them right. That is just not the way this course works. We are learning from the homework sets, and we want it to be that way. We don't want to have homework sets that are just so easy that it's a waste of our time. We want to be learning from them. Tests in this course, again, anticipate a test at the end of every unit. And if we back up here, that's a bunch of little summative assessments that we'll have on all these. That's so the students can check their understanding, and I can keeping an eye on them, making sure that everything's going well. Tests are may be the format. I always want them to be similar to the AP exams if they're getting used to that format. And I know it's going to be a little awkward with online learning because one of the key things about the AP exam, of course, is that it's a timed exam. You have a certain amount of time to do the problems. And so I'll be expecting students to give themselves that time, that same sort of time, and restrict themselves to that and try the problems in that much time. Let's see. Textbook, again, reading is expected and essential. It's online. We talked about the conceptual questions that the author, Craig Fletcher, did. They're very, very nice. Every problem in the text has full worked out solutions available there online. Homework assignments, got to do it. Okay, there's just no way to get through. Just got to make sure they're keeping up with it, and it's going to be brutal, and to a certain extent because it's challenging. The problems are rough, and there's going to be times where your student is just kind of, beating their head against the problem and trying. That's why it's important that I do have the solutions posted, and this is when office hours comes in. They are welcome to email me anytime and set up. We can set up office hours where they can come in. I can Zoom session, work with them one-on-one if they'd like. In class, that's a good time to ask questions. If they have a question, odds are very good other people in the class have the same question. They should not be shy about interrupting me and saying, Mr. C, Mr. C, and I will pause and deal with it as best I can. And then, of course, they should be actively participating. During Zoom sessions, they should be taking notes and going through and trying the problems that I typically in Zoom sessions, I'll pose a problem for them to work through right then so they can get feedback right away. But the Zoom sessions, like I said, the hope is that usually they'll be getting material through videos that I'll record or provide them links to, because I want the time in class not to be about me delivering bulk material, although I do enjoy lecturing, but it's about I enjoy doing demonstrations for the students and so on. But it's an opportunity for us to get deeper in things that there will be some topics that you just really want to have someone verbally explain to you rather than just reading or watching a canned video. Some of the more tricky ones, but in particular, it's a good time for me to give them some questions that make them think and check their understanding and maybe prompt them to ask some questions that they may have. And it's a good time when for us to collaborate. And so I want to keep the, just bulk dissemination of information to be through their textbook or through videos. Speaking of which, one of the things, video site that they're expected to use and videos they will be assigned to watch regularly are these videos put together by this teacher named Byron, apphysicslectures.com. They are fantastic videos. And at the end of each section, there's some videos that are like kind of review problems, and they're great. They're really nice. A lot of times they're very much like problems that are on the AP. Those videos, the teacher presents a problem and then asks you to pause the video and then work it out and then unpause, and he immediately runs to the solution. And it gives students that kind of instant feedback. It's really so valuable. The last thing is to use friends to help. Obviously, when we're doing tests, they're meant to be individual checks on your individual understanding, students' understanding. But when they're studying, working on problems, getting ready for tests, studying with friends is expected. When they have to explain and answer each other's questions, it really helps them learn to a deeper level. When you have to explain something, you have to think about what's the most important features and the critical parts of this concept, and how can I relate it, and how can I put it in different words. It makes them think on a deeper level than they would if they didn't have to explain to someone else. You can ask just about any teacher when it was that they felt that they really, really understood their subject matter, and a lot of them will say, I thought I understood in college, but it wasn't until I had to teach it that I really grew in my understanding of how everything really works. So that's really kind of like the best advice I can give. And the last thing I would say is just a reminder that the best way to get a hold of me is through my email. And again, I check this email every day pretty much. Again, this is the normal school email account that is linked off the school website. Go to faculty and staff tab, go down to science department. If you do that, you'll also find that there's a phone number there that makes like the office phone at Waubonsie ring. But when you leave a message, that voice message will go to my email inbox. So I'll get it that way too. If you go through Parent View, that's a different email account, which is new through that company Synergy that puts together Parent View. And you can leave me a message there too, and I'm going to attempt to regularly check that email too. I just need to get used to it. And that is, I think, what I had for you tonight. If you have any other questions, again, feel free to contact me. Encourage your students to make good use of office hours. A lot of times honor students, they're so used to things going easily for them, relatively so, that they pick things up, that when something comes along that's really challenging, sometimes they mistakenly think, what's wrong with me? Why am I not getting this? Some of the students are picking it up real quick and I'm not. It's not that. It's tough material. It is challenging material, and you are intended to come to office hours outside of class. That is the intention, and it's good for you. In fact, when I talk to my graduating seniors and I give them advice at the end of the school year, and I'm like, hey, here's your best advice I give for college. The number one piece of advice that I give them is to get to know their profs and to go into office hours. So anyway, I'm just going to wrap this up here. Have a good evening. Hope that this was helpful. Again, contact me if you've got any questions. Good night.